Okay, you're going to come up against some that seem mismatched, and you might go, there is no way I can do that problem because we've been doing sine and inverse sine, cosine, inverse cosine. What do you do when you have cosine and inverse sine? How is that going to work? Also, I take a look here and holy moly, that's not any of the exact values that I know. How am I going to find the exact value in radians of this answer? Well, let's take a look. One thing we can do instead, all right, is use a right triangle. Okay, so let's say here's my angle. What does sine inverse of 8/17 mean? It means what angle has a sine of 8/17. So remember, when we had right triangles, the sine of an angle, say this is my angle A, is the opposite over the hypotenuse. So this angle A in this drawing would have a sine of 8/17. We want to know what would the cosine of that angle be. That's what this is asking. What is the cosine of an angle who has a sine of 8/17? We've done problems like this before. It's just cleverly disguised. Okay, so again, we go, okay, where would the angle be in the triangle? It would be here with a side opposite being length 8 and the hypotenuse being 17. We want the cosine of that angle. So first we have to find out what this missing side is because cosine is adjacent over hypotenuse. So we use the Pythagorean theorem, okay, to find that missing side. All right, so we put in our pieces. We don't know our adjacent side. We do know the other leg is 8 and the hypotenuse is 17. My order is important there. The hypotenuse must be this one that's over here. Okay, we add a squared plus 8 squared is 64 equals 17 squared, which is 289. We subtract 64 from both sides. And we get a squared is 225. And finally, we take the square root of both sides. We find that our missing leg is 15. So the length of this side here is 15. So we're able to answer our question now. Again, this means inverse sine or arcsine of 8/17 means what angle has a sine of 8/17? It would be this angle here in our triangle. And then when we do cosine of that, it says what is the cosine of that angle? The cosine would be the adjacent over the hypotenuse, or 15/17 would be our answer. Now notice that is an exact answer, okay? Not necessarily in radians would be if we're asking for the angle, okay? So this is the exact answer. The angle the cosine of the angle whose sine is 8/17 is 15/17. Okay, I'm going to show one more example of that. So again, you would come up against this one and say, oh, I have cosine and sine mixed. You would also notice 24/25 is not any exact value that I can recall. So then we go, well, we're going to have to resort to the old right triangle on this one. Pick an angle A. Okay, here's my angle. So again, this part means what angle has a sine of 24/25? What angle has an opposite side 24 and a hypotenuse of 25? Because sine is opposite over hypotenuse. And then here, what is the cosine of that angle? Well, to find the cosine, we need the adjacent side over the hypotenuse. So we know it's something over 25, but we need to find that missing leg so we can finish the problem. Again, since it's a right triangle, we would go with the Pythagorean theorem. Okay, all right, so we have a missing leg. The other leg we know of is 24, and our longest side, that hypotenuse, is 25. I'm going to square those, so 25 squared is 625. 24 squared is 576. And a squared is a squared for now. We're going to subtract 576 from both sides. Which leaves us with 49. And then we just have left to take the square root of both sides, and we get a is 7. So the missing side of our triangle was 7. So to answer our question, what is the cosine of the angle whose sine is 24 over 25? Well, this angle A had a sine of 24 over 25. Its cosine would be 7 over 25. And there you go. Okay, so that is a little change up when you have the cosine and sine reversed and have to find the missing value.